welcome. In this lesson, we are going to look at confidence interval for mean large sample. So we are going to take examples and see how to solve them. Now look at this question. A sample of 81 observations is taken from a normal population. The sample mean is 40, and the sample standard deviation is 5. Determine the 95% confidence interval for the population mean. Now to do this, someone will be asking, questions for small sample and large sample, they always look similar. How do I know this is a large sample and how do I know this is a small sample? Please, the only way you can know this is a large sample is that when your number of trials or the selection you've done is greater than or equal to 30, if the population is normal and n is more than or equal to 30, it is a large sample. That is one. Another way in which you can know if something is a large sample or not is that when n is less than 30, but not just less than 30, but the population standard deviation is known. When n is less than 30, but the population standard deviation is known, it's also a large sample. Okay, but when n is less than 30 and the population standard deviation is unknown, that is when it is a small sample. But for now, we are looking at large sample, so let's concentrate on this. So when n is greater than or equal to 30, irrespective of whether it's a population standard deviation or sample standard deviation, it doesn't matter. What you know is since n is greater than or equal to 30, that's if n is 30 or more than 30, then it's a large sample. But when n is less than 30, you can't say if it's a large sample or not, but you need to actually check the standard deviation that it is. When the standard deviation is a population one, you can still call it a large sample. So let's look at this question. When you look at this, they say 81 observations. So the n is greater than 30, so it's a large sample. That's how you know that it's a large sample, okay? So for large sample, we use Z, and for small sample, we use T. So here we are going to use Z, okay? So to estimate confidence interval, the formula is sample mean, that's X bar, minus Z multiplying standard deviation divided by root n, less than mu, less than sample mean, plus Z multiplying standard deviation over root n. When you check some slides, some people write it like this: sample mean plus or minus Z multiplying standard deviation over root n. It's still same thing, okay? You are just trying to compress this together so that you won't be repeating certain things, okay? But it's still the same. You can use either of them, but I am using this in this video, okay? Now let's find a sample mean. What is the sample mean over here? They said the sample mean is 40, so you're gonna write 40 over here, 40 minus, how do we know our Z? When you look at the entire question, you've not been given Z. You need to find a Z yourself, and to find a Z, you are going to use the confidence level to find a Z, the 95% confidence. Now pay attention please. To get the Z, we are going to find something we call area to the left. Area to the left that's area to the left of Z, okay? Or area to the left of positive Z. You are finding area to the left of a positive Z, okay? It should give you C plus 1 all divided by 2. What we mean by this C is that the confidence level in decimal, 95%, okay? In decimal is 0.95 plus 1 all divided by 2. So quickly, when you take division, 0.95 plus 1 all divided by 2, you're gonna get 0.975. The calculator give it to you in 3 decimal. You can make it in 4 decimal place, so 0.9750. So that is the area to the left. So you take your Z table. Now mind you, I'm using the full Z table. I'm not using the half Z table. For the half Z table, this place starts with 0.0000. That's the half Z table. but this is a full Z table, so this is what I'm using. Okay, now if it was a half Z table, you would have subtracted 0.5 from this one before you check. Okay, but there's no need, we are using the full Z table. So you look for 0.9750 among all these probabilities, all these areas. So let's search for 0.9750. so let's search for it. 94 is here, 95 is here, 96, okay, 97s are here, so let's check them. There's 9706 here, 9732 is here, 9738 is here. Okay, yes, we've seen it. So this is 0.9750, as you can see clearly. Now what you're going to do is that where you've located a 0.9750, when you check it towards the side, what do you see over there? 1.9, isn't it? When you trace it upward, there is 6 over there, isn't it? So this means 1.96, 1.96, that's the meaning. 1.96, okay, 1.96. So our Z, our positive Z score is 1.96. Now since you've gotten this to be 1.96, you can now substitute it there. So 1.96 times Z standard deviation means Z times, just that I didn't bring the multiplication, but you should know there is a multiplication sign between them. So what was our standard deviation? Our standard deviation was 5. Now please look at something. When you look at this question, they said sample standard, they didn't say population standard deviation, but it doesn't matter, please. As long as, or as far as the n is more than 30, it is already a large sample, so it doesn't matter. You just substitute the 5 over there, divided by root. What's our n? 81. Less than mu, less than, so you repeat same thing, only the sign will change. That's 40 plus 1.96 times 5 over root 81. So quickly, you have 40 minus, when you calculate this, you have 1.96 times, that's Z times standard deviation over root n, 1.96 times 5 over root 81. When you do it, what do you get? You get 1.0888, that's 1.09. okay, so you get 1.09 in 2 decimal places. 1.09 in 2 decimal places. In 3 decimal places will be 1.089, but I'm leaving this in 2 decimal places. Okay, less than mu, less than 40 plus 1.09. So quickly, when you take 40 minus 1.09, you get 38.91, isn't it? Less than mu, less than 40 plus this gives you 41.09. So you are trying to tell me that the population mean it will be between 38.91 and 41.09. That's the meaning of what you've done. You've taken a sample, you want to use a sample to estimate what likely the population mean will be. So that's what you are doing. So you are trying to tell me that the population mean will be between an interval of 38.91 and 41.01. okay, so this is the end. You can leave it in 1 decimal place as well, less than mu, less than 41.1. okay, but I decided to leave mine in 2 decimal places. You can also leave it in 1 decimal place, it doesn't matter. Now look at something. If you want to know if you are right or not, or you've done something wrong or not, you see, when you are done solving, the lower bound, that's the 38, the lower bound and the upper bound, you add them together and divide it by 2 to see if you get the sample mean back. Let's try it and see. 38.91 plus 41.09 all divided by 2. What do you get? See, you've gotten 40. Can you see that? You've gotten the sample mean back. After solving, add the lower bound and the upper bound together and see if you get the sample mean back. Let's use the one I've left in one decimal place, 41.1 and 38.9. When you do it as well, you still get same thing. So provided you've solved it very well, when you add the upper and the lower and divide it by 2, you get the sample mean back. You get a best point estimate back. Okay, so that is how to do it. So let's quickly take example 2. Now in example 2, they say a sample of 10 observations. Then as soon as you see 10 observations, somebody will be wondering that this is a small sample. It's no more than 30. No, it can be or it might not. So let's see if it is or not by reading the entire question. A sample of 10 observations is selected from a normal population for which the population standard deviation is known to be 5. The population standard deviation is known to be 5. This alone should tell you that it's still going to be a large sample. Though when you started reading, you were thinking it would have been a small sample because it's less than 30, but no. Since the population standard deviation is known, as I said earlier in my explanation, it's still a large sample. So this question is saying that the sample mean is 20, so determine the 95% confidence for the mean. So quickly, you write the formula, same formula, z multiplying standard deviation over root n less than mu less than sample mean plus z multiplying standard deviation over root n. So what's our sample mean? That's 20 minus, you have a 95% confidence. Same procedure you use here to find the 95% confidence to give you 1.96. You use same to get a z here. Okay, so we have 1.96. What's our standard deviation? 5. So times 5 divided by root. What was our n? There are 10 observations or 10 number of trials. So 10 less than mu less than 20 plus 1.96 times 5 over root 10, isn't it? So quickly, you'll find the margin of error. 1.96 times 5 over root 10. You have 20 minus, when you calculate this part, just this one, 1.96 times 5 over root 10, you get 3.099 less than mu less than 20 plus 3.099. Now please, I want to remind you of something. You see this part where you've calculated z times standard deviation over root n. Just this part is called margin of error. It's called what? Margin of error. So this is a margin of error. This is a margin of error. Here too, where you've calculated z times standard deviation over root n, just here is also called margin of error. Okay, so if a particular question is asking you to calculate margin of error, you should know they are just asking you to calculate z times standard deviation over root n. That is under large sample. This is what we call margin of error. So our margin of error here is 3.099, isn't it? So when we subtract 20 minus 3.099, we get 16.901, isn't it? Less than mu less than, when you add 20 plus 3.099, you get 23.099. So this is the final answer. You can leave your answer in 2 decimal place as well. It depends on you. 16.90 less than mu less than 23 point. This in 2 decimal place will become 10. Okay, you can apply same trick we use here, that you add your 2 ends, the lower end and the upper end. 16.901 plus 23.099 and divide all by 2 and see if you get the sample mean back. 20. As you can see, we got a sample mean back. That's how you use to know if you've done the right thing or not. Now mind you, when you leave the lower part in 3 decimal places, make sure you leave the upper end too in 3 decimal places. When you leave the lower end in 2 decimal places, make sure you also leave the upper end also in 2 decimal places. Okay, when you leave the lower end in 1 decimal place like this, make sure you leave the upper end too in 1 decimal place. It's very important. Thank you. This is the end of this lesson.